So let's look at the locus of a point equidistant from a line. So we could be having a line. Let's call it AB. A line can be limited. And we are told there is a point which moves such that it is equidistant. Let's say it is 4 centimeters away from AB. It moves such that it is always 4 centimeters away from AB. So what we do, we look for the ruler and measure 4 centimeters. We measure 4 centimeters. We make an arc here and another arc down here and another arc here, another arc here. Now, then we take our ruler and draw tangents to these arcs, lines that just touch these arcs. Then also down here, so we'll have the loci. Remember, they should not exceed that point. We should always, this line is always, let's say, 4 centimeters away from A. The perpendicular distance is 4 centimeters. The distance is always 4 centimeters. Whether it is here, make sure it is the perpendicular distance. Now, what happens when the point reaches this end? It will form semicircles. It will form semicircles. Because it is always 4 centimeters away. So, what can we describe this as? Is a pair of parallel lines at a distance D on either side of AB, of line AB. But it also forms semicircles at the end. At both ends. So this point, if it is here, it will always be the same distance. If it is here, the same distance. If it is here, the same perpendicular distance. If it is here, the same circular distance. So that is the locus of a point equidistant from a line. So you might be told in a question, inside this triangle, there is a line, there is a point, find the locus of a point that moves such that it is always 3 centimeters away from line PQ. So you have to get 4 centimeters away. but inside the triangle. So it's not always on both sides. It depends with the nature of the question. So let's look at part E. Angle bisector loci. What is the locus of a point equidistant from two intersecting lines? So we could have two lines that are intersecting. OA, OB. They are not necessarily equal. They could be equal in length, but there are two lines that are intersecting. What is the locus of a point that moves such that it is equidistant from the two lines? Rather, it is in the middle. It is in the middle. Therefore, this is an angle bisector. So the way we were bisecting an angle, you take your pair of compasses, make an arc there, another arc there, an arc there, another arc there. Take your ruler, draw a line through O, passing through this other point. That is the locus. Why is it? So, because the perpendicular distance is always the same. So this distance is always the same. The perpendicular distance from here to here. So this point has to move in the middle of this line. So that is what we call the angle bisector. So let's move to the other two.